In this next session, Tarek Omar from the Cairo Hackerspace is going to introduce to you what he has been working on in the meantime, especially when so many of us couldn't visit our local makerspace. Come with us on a little demo and journey to discover the remote lab. Hi, Tarek. Great to have you here.
Hi, Geraldine. Thank you.
I would love to ask you to begin by giving us a demonstration of what you mean when you say remote control lab, and introduce us to Senet Lab, please.
Okay, so let me begin by sharing the screen and going to right to the Senet Lab website. So Senet Lab is a platform that we built at Cairo Hackerspace related to the pandemic, the COVID-19 pandemic. When it started, we couldn't begin doing workshops or events or any of what we do. And a lot of people were asking us to, they needed hardware, and we thought about lending hardware. We thought about the mobile makerspace we did before, and nothing worked in that setting. But then we remember something we thought of a long time ago, which is we were thinking about sharing our lab online and also shared with other countries. And we were thinking about, like, if every hackerspace or a makerspace are able to share some of their instruments for students and makers and hackers everywhere in the world, so they can learn on it. A lot of things doesn't really need you have the hardware in hand. Mostly you program it, you monitor it, you control it, related to most experiments. So we started Senet Lab. It's still in development. This is like right now, like early beta. And the whole idea of it is to have the hardware easily shared and controlled from anywhere in the world. So we thought about what would make the process easy, and the first thing we thought of, we get a lot of people in the hackerspace who does not even have computers, and they want to use our own computer. So we thought everyone have either phones or tablets. So why don't they have a virtual machine on the cloud that they can create this? So I'm going to show you right now. The first thing we did was we created an online virtual machine. So I'm going to, I hope I wrote that right. Republica. Okay, let's actually make it very correct. Republica 21. And then I'm creating a virtual machine right now. It's Ubuntu. It's a version of Linux, and this is what most engineers and scientists and developers and people learning use. And basically, you can do anything that you would do on Mac or Windows, most things. So I'm gonna, just like that, I'm gonna create a new machine. And let's imagine right now I'm the teacher or the professor or the person who's doing the workshop. And right now I just created the virtual machine. And then once I set up this virtual machine, I can go, it's like computer, it's like desktop. I can go inside, I can set up my examples, I can set up software that the students, they will use. And I'm gonna just make a quick example here of, let's say, Visual Studio Code. This is something familiar to people who know that they use it to do programming. So if I have an online lesson for people to learn Python programming and do AI, we can actually use this. And once I am done setting up my examples, I can save it and set up all the hardware and save it. I'm gonna go back quickly to show you something before I go to the hardware. I can actually come here as a professor and I can allow this machine to be cloned or collaboration, right? So mainly the cloning right now. And I send this code to my students. I actually use this personally. I have about 10 students I teach online, and I use this platform with them in hardware and software. So when I send them this container, they are able to clone my virtual machine with everything I had in there, and they have all the examples and everything set up. The collaboration feature, we have it for our students. Let's say my student have a problem. So when they check this and they send me their code of their own virtual machine, I am able to actually go inside and we both are collaborating on the same machine. So it's like Google Documents, for example, where multiple people can join. So I do use that feature with actually one of my students that I teach Python programming language. And every lesson we collaborate on one machine and we work together to learn that. The main feature, which is the remote lab. This is a lab also, but the main feature is attaching hardware. So we made it very easy for anyone who have an account on Senet Lab to download the Raspberry Pi image. So everyone, a lot of people know Raspberry Pi is single board computer. And just by one click, when you go there, device manager, when you click request image, you will get just a file. You download that file on your SD card, put it in the Raspberry Pi. And then I'm gonna go back here quickly. Sorry, I'm going too quickly. And then anything I connect into the USB port for that Raspberry Pi will actually appear here, or I can share it. It also has a code. I can just send that code, like the virtual machine code, to my student, and then they will be able to do that. So here I have sample codes for two of my colleagues working with me for their own Raspberry Pi and whatever they are using. So this is a Raspberry Pi right now that has an experiment that related to motors, okay, to learn how to control motors with PWM signal. So I'm not gonna go into the technical terms right now, but it's how you do, it's like modulation, how to make a signal to control how fast the motor rotates, the speed and the direction of that. And right now the camera is going to, it should appear right now, hopefully. That's what happens in the demos. So yeah, as you can see, the camera right now appeared. I'm gonna show you exactly what you see here. I'm gonna do this so everything is clear. So right now I have the camera. This is the motor right now, and I am going to leave this. So this is right now, I can light around, let's say this is a lecture, and I'm showing you an example. And then later, at any time during the week, night, morning, you can just go attach the machine and try to do the assignment. I gave you an example, the assignment, and I told you like, hey, using what you learned in the classroom right now, I want you to program this circuit. It looks messy a little bit. So yeah, until the program opens, I'll tell you what exactly we have here. So what we have here is like, this is an oscilloscope. It's a digital oscilloscope. And this is the motor with a propeller, actually a drone propeller. And this is a power supply that's supplying power to the propeller. And what do you see here is the software that generates the wave and that can control the motor. So right now I am going to turn on the motor. So the motor is actually, so these switches, I will tell you quickly what is this. So right now this determines the direction of the motor. So, and right now the motor, I think it should turn into clockwise. So let me just make this a little bigger. Okay, let's get this out of the screen. Like this, and then we can generate right now the pulse. So when the motor receives the pulse, it is going to turn. It should. Okay. The motor is not turning. There is a pulse. Okay. I think I have changed it. I have changed something. The power. Oh, okay. Oh, I see. I see. The pulse is too weak. So let's change the pulse here. Okay, I don't see the motor turning, but it works. So I think it's I changed it something here. Okay, so yeah, from here. So basically, to make the motor rotate, we need to send the motor a specific pulse. And as you can see here, this is the pulse that the motor is getting. And this pulse should be 5 volts. So it's 5 volts on and off quickly. And that determines how fast the motor rotates. And when I click run here, it should make the motor rotate. And sorry about that. So here, that determines in this area, that determines the direction of where the motors should, the direction of the motor. I can change the speed right now. I'm gonna make this window away. As you can see, all of these windows are in the browser right now, and this is similar to on a tablet or a phone. And this is like game streaming. If anyone hears about game streaming right now, we are doing the same. We are streaming the keyboard and the mouse back to the clouds, and you get this view streamed back to you. And you can install any software in this setting. So basically, right now, what happened is the camera is going to stop right now, and this is a good feature we created so that the students can have cues. So right now, as you can see, I mounted this, and now it got unmounted after 300 seconds. And the reason is, if we have 100, if I'm teaching right now and we have 10 students, they can get their turns in the queue, and I can have this experiment like 4 of them or 3 of them. And that's actually what I do with my students. Sometimes I have multiple students and I have only one experiment, but I leave it on forever. Just plug it in and go to sleep and don't have to worry about it. So I'm going to mount it again. And as you can see, mount it for 300 seconds. I'm just going to close this and open it again so it can, and then the camera, it's going to come right now. So yeah, basically that's one experiment. I can show you also another experiment with Arduino. So yeah, I did this like a quick demo. As you can see, the motor is turning. I mean, yeah, this is basically like summary of it's working, and you can plug in anything. You can plug in any kind of experiment or like something you would need just to monitor the data, and you need a specific software for it. And you can do this remotely. I use this even at work, and sometimes at work at my day job, I do I build escape rooms and I build exhibits, and these things sometimes break, and sometimes it's impossible for me to go, and I don't even have my laptop. So I leave a Raspberry Pi there with the OS. Once they just plug into the Raspberry Pi and put the USB in, I have full access and I can see everything happening. I can just program it or debug it or change it or do anything. So
thank you so much for the brilliant demonstration, Tarek. It's great to see Senet Lab in action.
Thank you very much. Oh, let me stop the share. Okay.
Yeah, I would love to ask you a couple of questions to follow up your presentation with. So I think you explained so well in the beginning, the inspiration point, like during COVID, you were in a city where it was a really difficult situation for a long time and people couldn't really go anywhere. So it's clear where your sort of point of departure came from. I would love to learn from you what your hopes are for Senet Lab, how you think it's going to be in effect to give more people perhaps access to these kind of educational opportunities and learn spaces than previously you've had.
Yeah, as I said before, we had that exact problem for a long time, and talking with my friend in the gigs, like friends in the gig network, and mostly the same problem exists in a lot of African countries, which is it's hard to get the experiments, the hardware. There is a lot of things that are open source, but not everything is open source. And even building the open source things, you cannot do everything. Some hardware is expensive. In case of Egypt, for example, I cannot get all the hardware. The price also, like the very cheap things like the Arduino is right now very expensive in Egypt because of the difference in the price and the economy and all of that. So even the very cheap things that you can say it's like $1 or $2, it is actually now challenging for the education reason. And most of these things, you don't actually need the hardware in your hand. So it was the time, like we had the time right now to build it of a vision we saw long time before. We needed this. We tried, as I said before, we tried to help other places in Egypt to open hacker spaces. And one of the issues was there is no accessibility. And we tried to make the accessibility, but it didn't really work. The things need to be always there or needs to be always accessible. And right now I'm sharing my own hardware with my friends in Cairo Hackerspace and also my students everywhere, like in the US or Europe or in Egypt.
Right, so it's not just something that's to be used during the pandemic and in the times where we can't necessarily go to our makerspace or hackerspace of choice, but also especially to create access for people who don't get to go to such kind of spaces at all, or that are under-equipped. I think this is such a beautiful continuation of some of the work that you've been doing. As you mentioned really briefly, you set up Cairo Hackerspace, but also put that in a mobile van to take it to places where people didn't have access to the space that you were providing inside a capital city center, and now taking that to the virtual realm to give even more people access. I think, yeah, like I said, is a beautiful continuation of that. And like you rightly pointed out, some of the people in our network live in countries where you have up to 400% import tax for hardware, and even smaller devices like Arduinos or Raspberry Pis that seem generally affordable can become hugely expensive in a setting like that.
Yeah,
so
that's correct.
How are you developing it at the moment? You said it's in beta mode, and what are the next steps for Senet Lab?
So currently, all the team working on Senet Lab are Cairo Hackerspace members. And yeah, as I said, the reason we wanted to do that because we don't want to. We have been through a lot in Cairo Hackerspace, a lot of extreme things, and this was like we are trained right now, so we never stop. So that's why we instantly started working on that. So it's the Hackerspace team working on that. A lot of the developers that working right now on Senet Lab are actually interns. Some of them, it was the first time ever writing code, and I did that because I was like, if that project failed, at least someone got the benefit, and this is the mission of Cairo Hackerspace. So we teach people things from different fields. The current state is we are trying to make the main features more stable. The main features we have, which is like the virtual desktops that you can spawn with one click or share or collaborate with in 1 second, and also be able to share your own hardware, any hardware that you can plug with USB to be able to share that. We're trying to make that more stable and intuitive and easy as like one click. You can have your hardware shared with your students or other people anywhere in the world. And then we want to add extra features that are mainly targeted for open science, which is like easier feature for AI and monitoring science experiments. So you don't have to go inside a virtual machine and set up everything by your hand, but now you can have like a dashboard with the camera and that's it. So we will be moving into that after this setting I showed would be more stable.
That's really exciting. I mean, I can imagine so many different ways that this can be used in future. And I maybe as a closing question would just love to hear if people were listening to this and think like, oh, I want to use Senet Lab in my educational setting, or I want to help develop this product, then what's the call to action? Can they get in touch with you? What would you say?
Yeah, so we are actually right now so right now I'm the only user, actual real user for Senet Lab, because I do actually use it with my students every week for the past 3 months. So I'm discovering new ways this could be helpful. Every time I show it to someone, they tell me, oh, this could be good in this problem, this could solve that problem. And I'm looking right now for organizations or people or spaces that would actually use this as a beta testing in a real classroom setting. Like I'm looking for a real classroom setting so we can work on making the features more stable. And I can be you can just send an email to info@senetlab.com and I will be responding to you. And yeah, that's what we are looking for. And we are also looking for support or funding, because this project we have been working on for the past year, since like we started actual development in May 2020, and it was all volunteer work and personal funding. So right now it did actually slow down a little bit because we ran out of funding, and some of the people working on it are students, so they are trying to keep up with their studies also. So we're looking also for funding and beta testers.
I hope a lot of people get in touch after they heard the session and watched the session. And I just want to say thank you for the amazing work you're doing. I so look forward to see where this is going to go and hope to be part of the further journey. And thank you for being a member of the Git community and taking part in this year's Republica program.
Thank you very much. Thank you, Geraldine.